I'm Claire and I work at Google Arts and Culture, where I get to work with some really remarkable people and partners on some really inspiring projects. I lead our sustainability program. Next slide. What is Google Arts and Culture? Well, we're a non-profit part of Google, and we partner with museums, archives, non-profit institutions, artists, creatives, and more around the world. And we work together to bring new ways to interact with culture. So we have over 3,000 partners in over 90 countries. Next slide. We build free tools and technologies for cultural organizations to showcase archives and stories with global audiences online. Next slide. We use several technical tools, so technology such as art camera that takes photographs in very high resolution detail. We do street view captures as well, where you can experience art and culture as if you were there. And we have a tabletop scanner where we kind of use this as well to capture fragile manuscripts, for example, from like national archives. Next slide, please. You can learn with more than 115,000 expert curated exhibitions, and you can play with our fun filters like Art Selfie, our 3D immersive tools like Pocket Gallery, and you can travel also to over 80 countries through virtual tours in 360. And we also help preserve World Heritage sites, and we've done this for over 100 endangered sites, and that's growing every day. Next slide, please. So to give you a wider context on our collaboration today and our project, I'd like to present to you our sustainability program very quickly that started over 5 years ago. And it started because we felt the need to create bridges between science, the broader public to communicate about climate change and our natural world. And it's never been more important than today. Next slide, please. We have two ways of doing this, so two focuses. One is artists interpreting data and working with scientists and global institutions to create more accessible ways to understand the climate crisis. And we also engage and partner with institutions around the world to create stories about our planet. And these partners are scientific, policy, local experts, and we do that to celebrate nature and also highlight solutions. Next. And you'll see some of the partners here. We actually work with over 100 partners globally, specifically on climate and nature. Next slide, please. Why do we do this? Well, we believe that storytelling and positive technology are really crucial to the climate discussion. The subject is often very hard to communicate, and it often feels very distant and too large as a scale. So we can bridge that gap with artists and scientific collaborations and empower audiences with practical tools and technology so they too can make a difference. So we always put our partners first and we amplify content from experts. Next slide, please. To give you a bit more detail about the Artists and Climate Data program, so it's a residency called Heartbeat of the Earth. This project is within this residency, and Yiyun here is the artist who is part of our artist residency this year. So we work with artists to interpret climate data, and we've been doing that since 2020. We work in collaboration with the UNFCCC on this, and we have done for over 5 years now. And today we're also focusing even more so on creating positive and helpful tools with the help of technology such as AI. Next, please. We also have a hub that's online and free for everyone to use, and it's called Culture Meets Climate that's been online since 2021, and that includes voices from all these partners that you saw earlier on, so environmental culture institutions, and we celebrate nature and inform users through this. Also, our Heritage on the Edge program looks at the impacts of climate change on cultural sites and local communities, and we intend to continue collaborating and enabling global theme pages that inform on action-oriented and inspiring stories. Next slide, please. And to give you a bit of an oversight on our long-standing partnership with NASA, which has been fantastic through the years, we've actually been working on not necessarily on climate projects, but actually on space projects. One of the projects we did within the lab was NASA's Visual Universe, and that was using NASA's public API, where we explored 125,000 historic images stretching back to 1915. And we analyzed them with machine learning. So you see here the Google Cloud natural language that we used to extract keywords and information from the archive. And that exists online, and you can use that for free as well. And we also very recently collaborated on the solar system, where we can use Google search to learn about the topics. We've got 60 3D models of planets, moons, NASA spacecraft, and that's just all through searching on Google search. And that's online today. Next slide, please. And now I'd like to introduce you to Passage of Water. This is our latest project, and in a beautiful collaboration with NASA and artist Yiyun Kang. We looked at how we could use new data sets that are focused on freshwater availability globally and how this is managed. Why? Because there's an urgent need to communicate about the subject. Having done some initial research on this topic, I found that it became very clear that there's just not enough communication out there. And also, you know, there's a total lack of awareness of it in general in the public. And reports obviously are not being read by the public, such as the IPCC reports. So it's kind of our job to like distill those reports to make them more legible, more digestible for the general public. So how could we create something around water and around water availability, more digestible, but informative as well, without being too didactic? And so this is why we created a collaboration between NASA, who had the most incredible data sets. Why? Because they're new. And Karen here will speak about the data sets in a second. But this is the first time that you're seeing this data through this project. It's looking at the surface water of the globe and looking at how that's been managed. So also we've got historic data from GRACE satellite and this new satellite called SWOT that was launched in December 2022. And so we enlisted Yiyun's creative and storytelling expertise to transform this data into really stunning visualizations and storytelling. And we created an interactive experience, but also installation here at COP. And this project communicates about some of the solutions too. So you'll see the story of water, why it's important, how much water we have left, but also we went to the IPCC, spoke with the IPCC, got some consultation from them about what the mitigation, adaptation methods and solutions could be that we could include into this project to make it less of an alarmist project too. If we go onto the next slide, sorry. So we have an installation here in the Luxembourg Pavilion, which is really just around the corner for you to visit. So please do come. And now over to Karen Saint-Germain, Director of Earth Science Division at NASA. Please come along.
Thank you so much, Claire. It's great to be here. This is as a storyteller myself, I really love this collaboration and the ways that we try to make science more accessible to more people. It is the key to optimism for the future, I think. So with that, let's go ahead to the next slide. So when most people, and I think if you hit enter, it'll animate. There you go. When most people think of NASA, they think of astronauts, the moon, Mars, maybe the Webb telescope. What most people don't realize is that the planet we study the most is our home planet. And this is the fleet of satellites that we have orbiting the Earth today, studying all different attributes of the Earth as a system, how water moves through Earth as a system. Each one of those satellites is sort of a specialist, and taken together, they tell the story of the Earth and how it works and how that system is changing. Let's go ahead to the next slide. So today, I'm going to talk about two of my favorites. The first one I'm going to talk about is a new one. It just launched. It's called SWOT. It launched about a year ago. And what SWOT does is it sends a pulse actually a whole lot of pulses, down to the surface of the Earth. They bounce, they come back, and by knowing the time of flight, we know exactly where, and knowing exactly where the satellite is, we know exactly where the surface of the Earth is. And in this way, we measure sea surface height. On the left, so you're looking just off the east coast of the United States. On the left, you see the very pixelated data. That is how we saw sea surface height up until December of last year from space. That's how we measured it. The image over on the right is what SWAT can see. So the red parts are areas where that sea level is a little above the average, and the blue parts, it's a little below the average. So you can see going from what we could do 2 years ago to what we can do now, it's like putting on glasses for the first time. And you might be saying to yourself, well, why is sea level different? It turns out that when there are currents and eddies in the ocean, they slightly change sea level to either side of the current or the eddy, and we can see that from space. So that's a big part of what you're seeing here. Let's go ahead to the next slide, please. And I think you may have to hit enter on this one as well. There you go. So we just, so it launched about a year ago. What I showed you was the first light image from SWAT. This is a composite. It took us 21 days to compile a global composite of sea level. That's what you're looking at here. And you can see these areas of relatively high or relatively low sea level all around the globe. These are those currents and eddies that we can now see for the very first time from space. We previously only had models of how circulation works in the oceans. And so you can see currents that you might be familiar with, like the Gulf Stream, for example. This also helps us understand how the oceans move heat around the globe, because about 94%, I know that sounds weirdly precise, but that's right around the number, about 94% of the excess heat that's trapped in the Earth's system from greenhouse gases is absorbed by the oceans. That's why we're not boiling on land, right? But this kind of data shows you how the oceans then move that heat around the globe. Most of it comes in right around the equator, but the oceans move it around the world, and that's why you're seeing changes in weather patterns, just as one example. Let's go ahead to the next slide. So the cool thing about SWAT, so that spatial resolution is now improved by a factor of 10. What that means is it not only works over oceans, but now we can see inland water bodies that we've never been able to see before. So what you're looking at here, and the way SWAT works, it doesn't collect data right under it. It collects data to the left and right. So you're looking at, that's the nadir track, that gray strip. So you're looking off to the right and off to the left. And this happens to be the Yukon Delta in Alaska. So that's the Yukon River, and then you see a lot of little lakes and ponds, and you see that the color is gradually changing. That's height. So the river flows downhill, right? So we can actually see the height of the river and the lakes throughout the Yukon Delta. We have never been able to see that from space before. Previously, we could see around 2,000 inland water bodies with that older altimeter. That's what we call this kind of instrument. Now we can see something in the neighborhood of 2 million. So it's a dramatic difference, including, and remember, this is not just showing you that water's there, it's telling you how high it is. So now we can measure things like how much water is in a reservoir. Is a river approaching flood stage, right? So, and we can also measure the height of temporary water bodies, otherwise known as floods. So previously from space, we could see that water was there, but we didn't know how much. Now we know how much. So this instrument is revolutionizing our understanding of inland water, fresh water, first global inventory ever. And it's revolutionizing our understanding of the physics, the physical oceanography, how the oceans work. I do carry on. All right, let's go ahead to the next slide. All right, now I'm going to talk to you about what might actually be the coolest mission we have. And this is a series. It started with one called Grace, and then there was a Grace follow-on, and I'm right now building Grace C. I call her Gracie, which is Grace Continuity. But this is, in most of our satellites, most of our observing systems, come on in, it's warm inside. Most of our observing systems have a satellite that has instruments on it, and the instruments look down. With Grace, we have 2 satellites, and they are the instrument. What we're doing is measuring the distance between the 2 satellites, and when those satellites pass over an area that has more mass under it, think of a mountain. Let's pretend this podium is a mountain. We have 2 satellites. Oops, I'm going to have to stay near the microphone. We have 2 satellites flying together. When the first one gets over the mountain, it feels more gravitational pull. That causes it to accelerate a tiny little bit. So he moves away from his buddy. And then as they continue to move, and the buddy is now over the mountain, he accelerates and he catches back up. So we're measuring the distance between the 2 satellites. That distance increases when there's more mass underneath the satellites. Okay, so you might be thinking, okay, but what's interesting about that? Mountains don't move, they don't really change all that much. Water does. Water moves. And water, if you've ever tried to carry a couple gallons of water, you know water has a lot of mass to it. So we can use these measurements to track the movement of water. And that can be in terms of ice on ice sheets. It can be groundwater. When aquifers are getting depleted, we can tell that from space because we know that there's not as much mass there today as there was a month ago. So this is the Grace mission. Let's go ahead to the next slide. Oh, you might have to hit, there we go. All right, now, how do we piece this together? We make all of these independent observations, and what you're looking at here, the bottom curve, that orange curve, is telling you how much sea level has risen because the oceans are warming. Because what do things do when they warm, right? They expand. So a portion of sea level rise is because the oceans are expanding as they get warmer. Another portion, and it's denoted in green, is water that's been added to the oceans. Water that used to be locked on land in the form of glaciers, whether that's mountain glaciers, Greenland, Antarctica. There's a lot of fresh water that was frozen and stored on land that is now melting, finding its way through rivers into the oceans. So water's getting added to the oceans. That's the green curve, and we measure that largely with the Grace instrument. We know how much ice has left Greenland, how much ice has left Antarctica, and how much ice has left the various mountain ranges around the world because the mass has changed. That's the green curve. When you add the orange curve and the green curve, you get the yellow curve. And you see how well that aligns with the blue curve, which is the measurements we make of sea surface height from the altimeters. So I just walked you through some basic mechanics of the science. This is what convinces us we actually understand what's going on. When different measurements and components of the system add up and explain the change, you know you've got it right. And why does that matter? Because once you understand, you can model. And once you can model, you can project into the future. And that's the kind of information people need. Let's go ahead to the next slide. And that's just sort of depicted here. We go from observations to understanding to then over on the right, predictive capability. That tool on the right, actually Claire mentioned, people don't actually read the IPCC reports. I have to confess, I could not muscle through the 6th assessment. In fact, I had a hard time muscling through the summary for policymakers. I'm not a policymaker. And I live and breathe this stuff. So if it's hard for me to muscle through, people who, aren't as close to these issues are going to have a hard time as well. So we collaborated with the IPCC and we created the tool over on the right, which takes the projections from the IPCC report, puts them into a tool so people can click on their coastal community and figure out what the different emission projections mean for sea level where they live, right? So sort of breathing life into this information. Let's go ahead to the next slide. And now I am going to handle, I don't even know if I said everything I was supposed to say, but yeah, let me just wrap up by saying everything we do is in partnership. The GRACE mission we built with the German Space Agency. The SWAT mission we built with the French Space Agency. We are partnering, we're here to highlight a different kind of partnership today, which is the partnership around getting that information and insight out. And so with that, I'm going to hand off to Yiyun and to talk to you about the rest of the project. Thanks.
Hello, everyone. I am Yiyun. I had a privilege of, for the entire last year, to work with Google Art and Culture Lab with NASA, JPO team, to talk about the story of freshwater. So I'm going to introduce how we came up, this connection, and then how I try to deliver the story through the lens of arts, and what is important to talk about this particular issue in this particular time. So for me, it's a completely different context because I'm an artist, but working with a lot of digital technologies, but still my main context is pretty much galleries or museums, arts venues, but here I can meet expertise, climate people, water people, scientists, engineers. So it's for me, it's also really variable experiences. So can we go to the next slide, please? Okay, so please click it. It's an animation. Yeah. So yeah, it's a collaboration between Google Art and Culture with NASA. And let's go to the next one. Yeah. So before I introduce about this particular project, I wanted to introduce. Let's next slide and play, please. Yes, I've been working with a lot of massive scale public installations. I've been interested in the relationship between human and non-human entities. Because as an artist, I've been working with the reality, virtuality, the projection mapping, and different materiality. What is digitality? What is immateriality? And I really. This one is about the what imagines about the future of the city, where we have to cohabit with the human and non-human, even digital entities as well. And then let's go to the next one. So this one is another massive scale public installation. I wanted to talk about the sixth mass extinction, and so that's kind of although it's a completely public space at the center of Seoul. It's beautiful, but at the same time, a little bit sad. If you go on to the next slide and play it, you can see a little bit of that installation. So I wanted to make some tributes to the vanished creatures because of the humanity. So it feels like surreal, fossilized skeletons, but somehow I wanted to give them a life at the public venue. So, and then let's go to the next one. So this one is a recent project at Chicago. I decided to title it as Only in the Dark because I think that we are entering a new dark age because of the climate crisis, unfathomable technologies, AI technologies. So I wanted to talk about this issue. It's like at the center of the downtown Chicago, so anybody can see it. So I try to use a lot of technology as much as possible, like AI, even human footages and 3D renderings in order to talk about, we also need to cohabit not just human and non-human, but also digital entities as well. So if we move on to the next slides, it's a short animation as well. The point is that I really love public projects. Because although I'm an artist, I want to speak to my story to the people out there, outside of the gallery, outside of the white cube. So for me, the working with the Google Art and Culture Lab is completely different opportunity to be much more public. So once you have the access to the network, my work can talk to anybody. So first, let's go on to the next slides. And then just before introduce about our passage of water, this is the last work. It's about the fire. So I've been so much interested in the fire because I think humanity is a creature of fire. From the Prometheus, we started, we were built on the basis of, burning out. And then because of that, we're having a lot of problems at the moment. So move into the next slides and play it, please. So it's kind of large-scale installation with a massive scale audio. So if you're in it, you feel like we're like burning up. Yeah. And then after this, I started to talk with Claire, and then we decided, we were making a project on water. So let's move on to the next one. And because we don't have the network here, I make a screen recording. So if you play it, so really amazing for me, this opportunity to hear, Karen's explanations about the swap, because I spent a whole year to understand about it. And how can I make the story understandable? Because for me, I think that data doesn't speak for itself, but art can speak for itself. And I wanted to translate. I wanted to be a translator. So then how can we do it? So the first part of the passage water explains that how freshwater is such a limited resource. I wanted to visualize it as impactful as possible so that anybody who has the network, they can see it, they should be able to understand it. And then I wanted to talk about the history of water. So at that point, I had a lot of discussions with the JPO team, NASA team, and they suggested to use a GRACE data sets because GRACE has collected the last 20 years of water, hydrology pattern on Earth. So I analyzed it with my team and we visualize it, but at the same time, if you can see here, it's totally navigatable. So you can play with the data. And it's kind of a sad story, because if you compare to 22 and 2020, you can see how dramatically changing. So what GRACE data tells to us, is that this is what we have done to the Earth. And then there's the SWOT comes in, and thanks to Karen, you know much better than me, but what SWOT does is that it can measure the heights of the water, so we can understand how much water remains, so that we can make better plans, we can better predictions, and policymakers, scientists, researchers can have better understanding of what is going on with the Earth. And this one is because we would like to focus on the freshwater, not the ocean, the whole water. So this is another visualization that collects all the river data sets that SWOT can detect. And from here, because we had the privilege of having the initial data sets of the SWOT. So it's amazing, but at the same time, there's a little, it's completely different from the GRACE. So GRACE has a history, but SWOT doesn't yet. So this part's a bit more speculative and artistic. It's more like artistic interpretation. What can we get from the SWOT? So we had a lot of discussions again, and we ended up with selection of 3 locations: Pakistan, Cairo, and Alaska. So I wanted to talk about different stories. All 3 locations have different crises, but in a very different ways. For example, the Alaska's melting glaciers, and Pakistan has unprecedented flood last year. So although it's an initial stage, but I wanted to cover different stories. So that's where it is. And then we had a lot of discussions, and then we didn't want to finish story there. Then it's just another fantastic visualization. And also, we are considering that we're presenting it at COP28, where a lot of policymakers and climate expertise will see. So we wanted to talk about what kind of solutions we have, what will be the sustainable solutions we have, and then how can we do that? So we decided to go for what about making a playful game experience? So to do that, we had sessions with the IPCC people. So what about the desalination? What about the rain harvesting? And then at the same time, it's not about pinpointing something. It's not about blaming something. Because, desalination is more of an important solution. But for me, the most important thing is that we need to understand the side effects as well. So it's because I'm an artist, so using visuals and sounds, I can deliver the message in a more nuanced way. So if you play this game, so people will think that, oh yeah, there's a saline, it could be not eco-friendly, and then what about the other option? So yeah, we could perhaps introduce rainwater harvesting. And because of the climate change, there are much more areas having much more rainwaters. So why don't we use it? So this is the last part of our online experience, introducing 2 different solutions. But at the same time, we only introduced 2 of them, but there are many, many more. Claire and I, we tried so hard to read the IPCC report. Yeah, it's so difficult. But so instead of introducing more, we could be bombarded. So in the information page, more page, you can read much more information in depth. We have all links to the NASA data sets that we use. We have much more mitigations, adaptation options. So if you're interested in, just continue your journey. So to finish, it's again, for me, I've been always working around, art and technology and creativity and criticality. However, I haven't actually had the opportunity to work really closely with the scientists. So for me, again, it's a huge, really amazing opportunity. So I wish our online project and offline project will be an opportunity to many people to talk about it more openly and to raise awareness. Thank you. Oh yeah. Sorry. Before yeah.
And just to close out the session, thanks all for coming. We do have a big, immersive, interactive installation, Passage of Water, where you'll be able to actually interact with all of this data yourself. It's in the Luxembourg Pavilion, if you click on the next slide. Next one. That's what it looks like. Next one. And the next one, where's the map? That one. So this is where it is in the Luxembourg Pavilion, number 93, which is just around the corner here, literally a 2-minute walk. Please do come in. It's actually really interesting to go through it yourself and be immersed in these stunning visuals by Yiyun Kang. So yeah, thank you for the invitation to come and speak today. Thanks, everyone.